In the last video, we had seen the first factor upon which the extent or the amount of friction depends. In this video, we'll look at the second factor upon which the amount of friction that is present between two objects depends. So the first factor was the type of surface, the nature of surface. So is the surface smooth or is the surface rough? The friction depends on that. The second variable or the second factor upon which the extent of friction depends is the mass of the object. So here I have a duster. So what I mean to say by mass of the object is that if this duster is heavier, I'll have more friction. So for this, I'll keep the surface the same, but what I can do is I can increase the mass and then see the amount of friction that I obtain from that. So before I actually get into the demonstration, I'll just quickly give you the reason why this happens. So let's take two surfaces that have irregularities like this, and the second surface. So if this surface is light, which means this doesn't have much mass or this doesn't weigh too much, then in that case the force that is pushing it downwards, which we know is gravity, will not be very high, which means these two surfaces will not be interlocked with that much amount of force, right? That makes sense. So these will be loosely interlocked, and when they're loosely interlocked like this, they can be easily moved, right? Because they are loosely interlocked, so the friction will be low. So if actually I should not say mass, actually I should say weight, because we've learned that weight is the force with which something is being pulled downwards. So if the weight is low or less, then the friction is also low, right? So if the weight is less, then the friction also less, because we have loose interlocking, and due to that loose interlocking, the objects can slide much easily and we'll have less friction. Now what happens if the weight of the object is high? If you have a high weight, if you have a large weight of the object, then what will happen is that this force that is pushing the block downwards will be high, right? Because that is weight. And now even though the surfaces don't change, the amount of irregularities don't change, but because this block is being pushed harder down into this second surface, the interlocking will become much tighter. And so earlier the interlocking was loose, but now the interlocking will become much tighter because they are being pressed together much harder. So we'll have a tighter interlocking, and due to that tight interlocking, the two surfaces will not be able to slide over each other easily. So that means that we'll have a high friction, right? So it clearly means a heavier block or a block with a higher weight, with larger weight, will have a tighter interlocking, and due to that tighter interlocking, we'll have a large amount of friction. So low weight means low friction, high weight or large amount of weight means more friction. So that is simple. So we've looked at the reason why this happens, how friction is dependent on weight. Now what we can do is we can perform a simple experiment to see if this is true or not. So what I'm going to do is I'm going to take here the duster as my object, as my first object, and obviously the second surface will be the table, and I'll pull the duster using a rubber band. And what I'll do is I can increase the weight of this duster by putting some object on top of it. So I won't be changing the surfaces. The surface will remain this duster, this surface, and the table. But what I'll be increasing is the weight of the duster by putting some objects on top of it. So here we go. So here I have the duster, and what I've done here is that I have attached a rubber band to this. So why am I using a rubber band? Well, you can clearly see the amount of force that I apply by the amount by which the rubber band is stretched, right? If I am applying very low amount, the rubber band will not be stretched, but if I am applying a large amount of force, see, the rubber band gets stretched. So this rubber band is an indication, the amount by which the rubber band stretches, that is an indication of the force that I apply. So the force will be much clearer and easier to observe by using a rubber band. So what I'll do is, first I'll just pull the rubber band, the duster, without putting any weight on the duster, and see how easy it is to pull this duster. See, by applying a very small force, I'm able to move the duster. Now what I can do is, I'll put a few coins. I'll put a pile of coins on top of this and increase the mass slightly, and see, I need to apply slightly more amount of force to pull the duster, but I believe even that is not clear. So let us take this to another level. So see, once again, just now observe the force to move the empty duster when the mass is low. Remember, the surface is not changing, only the mass, and thus the weight is changing. So the weight, or the force by the force with which gravity is pulling this object downwards, only that will be changing. Now what I'm doing is, I'll be putting a bottle on top of this. I hope you can see that. See, I'm just putting it on top of this duster, and I'm not changing the surface again. All I'm doing by doing this is increasing the mass of the duster. And if you observe here, see, if you focus here on the rubber band, I have to stretch it so much, still I have no motion, and this is due to the high amount of friction. Why is the friction so high? Because the mass has been increased. Now the interlocking is very tight, and therefore, see, I have to apply a very large amount of force, and only so much amount of force, in fact, I hope, see, and only then I was able to move the rubber band, move the duster. So that is clear. That makes it very clear that the more the mass, or the more the weight, the more the friction will be. So it is clear from this example. And yeah, so those were the two factors upon which friction was dependent. First is the surface, the nature of surface, if it's rough or smooth, and second is the mass of the object. So that's it for this video. If you have any doubts, you can ask me.